Hey guys, today we're checking out a deep dive of TypeORM and NestJS to show how we can integrate this powerful ORM and interact with a SQL database using NestJS. Now with TypeORM, we can easily implement repositories, set up relationships between different entities, use transactions, event subscriptions, and so much more. Let's jump right in to see how we can easily set it up with NestJS. I'll see you there. Real quick, if you want even more on NestJS and TypeORM, I'm working on a new module for my NestJS microservices course, which will use TypeORM directly and show you how we can work with it in a real-world setting on this microservices project. So if that sounds interesting to you, check out the description for a link to a discount to the course. I appreciate all the support, and I'll see you in the video. Thanks. So to get started, let's use the Nest CLI to initialize a new application. We'll run nest new. I'll call this project NestJS TypeORM. And I will use pnpm as our package manager and let our dependencies go ahead and get installed. Now we can run ls and see our newly created directory. We'll cd into it, and then we need to pnpm install the dependencies for TypeORM. So let's set those up now. We'll pnpm install nestjs/typeorm, TypeORM, MySQL2. We're going to use nestjs config, which internally uses .env to read in environment variables for our project. So to set this up, we need to pnpm install nestjs/config. Finally, we can run pnpm run start dev to start our local development server, which will watch for changes and compile and serve our application. I've opened up the project in VS Code. This is a default NestJS project with a main.ts that bootstraps the app and listens for incoming HTTP traffic on port 3000. By default, we have an app controller with one get route exposed, which is just returning a hello world string from our app service. Let's go ahead and test this out by opening up Postman and launching a GET request at localhost 3000. If we send this off, we get that hello world response back with a 200 status code. So we can actually go ahead and remove the app service and app controller files. We're not going to be using these in our project. So let's delete them. And then in our app.module, we'll go ahead and remove the imports as well as the controller and provider. Okay, our first step is going to be actually running a local MySQL server that our application can connect to. In our case, we're going to use Docker to run our database server because the setup will be easy and it'll work the same on every system. So to do this, we'll create a new Docker compose file at the root of the project, a docker compose.yaml. And here we provide a services key where we describe our first service that we'll call MySQL. You can call this whatever you'd like. Importantly, we now need the image name. We're going to use the default MySQL image from the Docker Hub repository. We next need to specify some environment variables for our MySQL server. Now we can do this by specifying them here in plain text with a key and value, or we can provide an environment file, which will be loaded in our directory and automatically provided to the container. This is going to be the more secure approach because we can add that .m file to our git ignore to make sure that the file doesn't end up in git, which would expose all of our secret credentials. So let's create this .m file at the root of the project, where we'll go ahead and specify the first environment variable needed, which is the MySQL root password, which is going to be the root password to connect to this database. It should be any secure value. I'll just call it random root password. Next, we'll need the MySQL database, which is going to be the name of the database that will automatically be created that we can specify here. I'll call this NestJS TypeORM. So now back in the Docker Compose, we can specify that m file, which will be the .env at our current working directory. And lastly, we'll specify a ports key where we actually expose the MySQL server port that's running in the container to our host machine where we're actually running the Docker image. So we want to map the port 3306 on MySQL server to 3306 on our local machine so that our NestJS application can actually connect to it. So next, you need to make sure that Docker is actually running on your system. I'm using Docker Desktop on my Mac to run Docker. If you don't have it, I'll leave a link in the description to get Docker Desktop. It's very easy to get up and running on your local system. So Docker's running in the background. Open up a new tab in the terminal and go to the current working directory for our project. And we will run Docker Compose up, which is going to go ahead and read our Docker Compose file and start the MySQL container, which starts up the database server. So you can see that our database has successfully started up and the server is ready to accept connections. Okay, so now that our database is running, I've opened up an application called MySQL Workbench, which is just a UI tool that will allow us to connect to our MySQL server. If you don't have MySQL Workbench, I'll leave a link in the descriptions where you can download it for your system. Here we have the ability to add a new MySQL connection. We can click the plus. We can call the connection local Docker or whatever we'd like. We just need to importantly specify this host of 127.0.0.1, which is just our local host address of our system, and then connect to port 3306, which is the port that MySQL server is bound to on our Docker container to our host machine. So that's how we'll connect to it. Our username will be root, and the password, we will click on store in keychain and enter in the password from our .m file. For me, it was random root password. Enter this in, click OK. And now if we double click the connection, you can see I've successfully connected to the NestJS TypeORM database, which currently has no data in it, but we can see this connection has been established okay. So now it's time to set up a connection to the database in our NestJS app. I want to create a new common database module where we can handle this connection establishment. So we can quickly and easily use the Nest CLI again and run nest generate module database into the terminal, which will create this new database module in a database folder, as well as update our app.module to import it. Next, we'll add an imports array where we will actually connect to our MySQL server with TypeORM. To do this, we will call TypeORM module.forRoot async, which is going to allow us to specify an options object where we're going to use the useFactory property, and now we can inject a service or any other dependencies in NestJS. We want to get access to the config service from NestJS config, so we'll have a parameter called config service of type config service from NestJS config. Then we go ahead and return directly in object, which will be the options for TypeORM. Now though we have access to the config service, we can actually read in environment variables from a .m file at the root of our project, just like we did in the Docker Compose file. Before we forget, make sure we add the inject property as well to the forRoot async object. And now we actually have to specify the config service again to ensure that it is available in this useFactory method. So also to make sure that we actually have the config service available to inject, we need to make sure we set up the config module in our app.module. To do this, we can add it to the first thing in our imports array. We'll import the config module and call forRoot on it. We're also going to specify isGlobal set to true, which just means that we don't have to keep re-importing the config module everywhere we want to use it. We only need to set it up once here in the root app.module. So in here, we'll start providing the options. The first one will be the type of database server we're using with TypeORM. In this case, it will be MySQL. Then we provide the host of the database. So we can use the config service to get the MySQL host variable. And we'll do the same thing for the port property. We'll call config service.get MySQL port. And even better, we can actually call get or throw, which will throw an error if these environment variables aren't actually found, which is exactly what we want to do. We want to throw an error if there's some problem configuring the application. So we'll call get or throw instead. Next, we provide the name of the database. We'll call config service again .get or throw. This time we'll call this MySQL database, which we know we already have defined in our .m file from our Docker Compose file. Let's keep on going and now provide the username, which will be config service .get or throw MySQL username. And we can copy this and paste it in and change this to the password, which will follow the same pattern, except username will now be password. So let's go back to the .env and provide all of this information. We'll add the MySQL host. We'll have the MySQL port, which is set to 3306. We have the MySQL username set equal to root. And finally, we have the MySQL password set equal to random root password. Now, like I said before, since this .m file is exposing sensitive credentials, this is where we'd want to go to the .gitignore file in our project and add the .env to it so that we aren't committing these credentials. I'm not going to do this so that the .env file is available to you guys in the GitHub repository to make this project run as easily as possible. So now that we provided all of the information to TypeORM to connect to MySQL, we'll provide two additional properties. One will be auto load entities and set this to true, which is going to make sure that we don't have to manually tell TypeORM where our models are and have to do that manually. We can just have it do it automatically, which is going to save us a lot of effort. Now finally, we have the synchronize property, which if we look here, actually will synchronize our database schema with the MySQL server on every application launch. So this will be super useful when we're developing locally. However, it could cause to data loss in production. So to make sure we check to see if we want to do this, we can make this an environment variable as well and call config service.getOrThrow MySQL synchronize, and we'll go to the .env and add this as well, MySQL synchronize, and set this equal to true by default. And if we were running in production mode, we could have a different .env file which would set this to false. So back in our terminal, we can see that the Nest application is still starting up successfully, and our TypeORM modules have initialized successfully, which means we have established a connection to the database and are ready to start writing and reading. So now we're ready to actually start creating our first entity using TypeORM and actually be able to create, read, update, and delete this entity. We can very easily generate this boilerplate code we need to create a new entity using the Nest CLI. We'll call Nest generate resource and call this resource items. We're going to be building sort of a virtual store where we can have different items for sale. So let's go ahead and generate this resource. You can see it's going to ask us which transport layer we're using. In our case, this will be the REST API. And then we're going to select yes to generate CRUD entry points. Nest has gone ahead and created a new items folder. Within this items folder, we now have an items module with an items controller and items service. The items controller is going to have all of the REST API routes to create, read one, update, and delete an entity using the items service. And in the items service, we just have some stub methods right now that are simply returning a text string. We're going to go ahead and replace this with our repository now that we can actually connect to our database. Finally, you can see our root app.module has the new items module added to it. So our next step is to create a repository, which is going to be how we actually interact with the database using TypeORM. In order to create a repository for our items, we need to fill out our item.entity, which the Nest CLI has generated in this entities folder. Let's start off by decorating this with the @entity decorator from TypeORM. And then we can continue filling out the properties that exist on an item. Now these properties are going to map to columns in the MySQL database for the item table. The first property we'll have on any resource in our SQL database will be the ID, which will be of type number. And we can specify that this is the primary generated column using the primary generated column decorator, which will make sure that this primary ID will be automatically incremented each time we insert a new record. Next, to just decorate a normal column, we'll use the @column decorator from TypeORM and specify the name of our item, which will be a string. Next up, we'll have another column, and this time I want to set a default value for it. The default value for this property will be true. So you can do this by specifying default true in the options object to the column decorator. This property is going to be called public, which is going to be whether or not the item is public or private. So now that we have all of the properties on the item, one more thing I want to do is create a constructor that actually will take in a new object, which essentially will be a partial of the item we've just defined. And then we'll call object.assign on this, which is the current class being created, and assign all the properties to it from the incoming partial of the item. This is going to make it really easy to create new entities in the future and not have to keep updating the properties in the constructor. We just need to pass an object that has some of these properties like the name and public, and our constructor will automatically assign them. So now that we have this newly created entity, we need to go to our items.module, and inside of the imports array, we need to create the imports array, and then we need to call TypeORM module and call forFeature on it. And here we provide an array of all the entities in the current domain. So all of the ones associated with an item, we need to provide to the TypeORM module here by just importing the entity and providing it to this array. So as soon as we do this, we can actually go back to MySQL Workbench. And if we right click on our database connection and click refresh all, we should now actually see we have the item table that's been created for us from TypeORM. As soon as we told it about the entity, it went ahead and synchronized our schemas as we've specified so that we have the correct table, of course, now with no data. So let's go back to our items controller and start actually fixing up our APIs to be able to support all of this CRUD functionality. To start off with our create route, we can see that we're extracting a body, and this is of type create item DTO, which has been created for us in this DTO folder. And of course, there's nothing here at the moment. Let's go ahead and fix this and specify the properties we expect when a new item is going to be created through our API. The properties we'll first expect will be the name, of course, of the item. And then we'll also take in whether or not this item is public or not. So have the public Boolean. Now, if we go back to our items controller, we're actually providing the body from the request to the item service when we call .create. So now that we have the create item DTO with its properties, we want to actually persist it to our items table. So our next step is to inject the entity manager from TypeORM. So let's open up a constructor where we take in a private read only entity manager of type entity manager from TypeORM. And what this entity manager does is it exposes a number of methods from TypeORM that allow us to interact with the database. So you can see we can execute raw queries with this entity manager, but importantly, what we can use it for is to actually save new records to the database, and that's what we're going to use it for. So let's go ahead and do just that. We're going to go ahead and create a new const here called item, and then we can just say new item. We just want to instantiate this new item entity, and we can pass in the create item DTO directly because this matches all the properties on the item itself, including the name and public property. We'll go ahead and remove this return statement, and now we will just call await this.entityManager.save. We'll go ahead and save, which we can see here. We'll create new entities if they don't exist. Otherwise, we'll update the entity. So all we have to do now is provide the item, and it will take care of everything to save this and persist it to our database. Make sure we set this method to async as well. Finally, go back to the items controller and we'll also mark this method as asynchronous. Now we're ready to try to create a new item. We can launch a post request at http localhost 3000/items, and we're going to provide a JSON body where we specify the name, and I'll call this first item and give it a public keyword of true because it will be public. So if we send this off, we get the 201 created response back. And if we go to our database and now re-execute the query to look at all of the items in our items table, we can see the item in the table here with the ID of 1, name, first item, and public set to 1. Okay, so next up, let's tackle the find all route here. So we'll change this to async as well. This is just a get route that returns all of our items. So if we check the find all method right now, we need to use the item repository to extract items just from the item table. Let's go ahead and do that by injecting a new dependency called the item repository. So we'll use @inject repository from NestJS TypeORM and pass in the item entity. Next, we'll specify the private item repository of type repository from TypeORM and specify the item as the type here. Now we have access to the item repository. We'll change the method to async, and instead of this text string, we're going to return this.itemRepository.find. Now you can see all of the different find methods available to us in this repository. We just want to call the generic find to get all the records. Finally, let's change this name here to items repository, which makes a bit more sense because we can return multiple items. Finally, let's make sure we add a read-only qualifier to the items repository just to stay consistent with our entity manager. So let's test out our find all method now. Back in Postman, we can launch a GET request at localhost 3000/items. And if we send this off, we can see we get an array of all of the current items. So we can even create another one by sending a different post request and saying second item as the name. Send this off to create the item. So let's keep on going, and back in our items.controller, we'll move on to the next route, which will be to find one entity. In this case, find one item. You can see it's a get route here that's taking a route parameter, and we're extracting that using the @param decorator and calling it the ID. So we can change this to an async method, and we're calling find one in the item service and providing this route parameter as the ID of the item. So to return just one entity with this ID, we can call this.itemsRepository.findOneBy, which will execute a where clause where we specify the ID of the item we want to look for. Let's change this to async as well. And now if we go back to Postman, let's add this route parameter to the GET request and say we want to look for an item with the ID of 2 and send this request off. You can see we're now getting back just a single item with ID 2. If we change it to ID 1, we get the first item back. Next up, on the update method, you can see it's quite similar. We have a route parameter of the ID of the item we are updating. So we extract that here in the first parameter. So we can change the method to async update. And you can see the second parameter is the actual update item DTO, which we're extracting as the body. So if we follow through where this update item DTO is in our DTO folder, now currently we're just extending the create item DTO in this update item DTO. I want to get rid of this and actually make this a dedicated class on its own, because I don't want to be able to update all properties on the item. I just want to be able to set whether or not it's public or not. So we'll just accept a public property of type Boolean. Now we're going to set item.public equal to the update item DTO.public, which is going to update it with the newly updated property coming in on the DTO. Finally, to save, we're going to call await this.entityManager.save and pass in the item object that has the updated public property on it, and TypeORM will automatically save everything for us in the database. Let's go ahead and test this out in Postman. We'll send a patch request at items/1 and provide the public property. And now I want to set this to false to mark it as no longer public. We'll send this off and get a 200. And now I want to get the same item back. So I'll switch to get this item back. And we can see that public has now been set to false. Okay, so lastly, our remove method, it takes a route parameter of the item we want to delete. We extract the ID and call item service.remove with this ID. To remove it, we can simply call this .items repository .delete and pass in the ID of what we're deleting. Let's change it to an async method, and then we will do the same inside of our controller. And now we can launch a delete request at /items/1 to delete this item. We get a 200 OK with a delete response back. However, I don't actually want to return the delete response, so we can go ahead and just call await this .delete. And now if we delete the second item as well, you can see we have a 200 OK with no response. And if we launch a GET request at all items, we should see we have now an empty array because no more items exist. All right, next I want to show you how we can implement relations in TypeORM, which essentially just abstracts the idea of joins between different tables in MySQL, and it maps it to different classes in our NestJS application. So there's 3 different types of relations that we will review. So the first relation is going to be the one-to-one, which is a relation where A contains only one instance of B and B contains only one instance of A. To make this more clear, we're going to add a new property to the item that demonstrates this one-to-one relation, and this is going to be called a listing. A listing will just be a bigger description of the item with different properties on it. So in our entities folder, let's create this new listing.entity.ts. And this will be marked with the entity decorator, as this will be a new entity with its own dedicated table, and we'll export a class called listing. This is going to have a primary generated column that's called ID of type number, just like our item. Then we'll add another column to add another property called description of type string, which will be the description of the item. And we'll add another column to represent the rating of this particular item. Then we'll go ahead and add a constructor that takes in the listing, which is of type partial listing, and call object.assign and provide this and the listing just like we've done in the item constructor. So now we need to go back to the item.entity and specify this listing is of type listing that we just created. And then we're going to mark this with the one-to-one decorator, which we can see here allows us to create a direct relation between 2 entities. Entity 1 has only one entity 2. Entity 1 is an owner of the relationship and stores the entity 1 ID on its own side. So we will use the one-to-one decorator, and we need to provide it the corresponding other type of the relationship, which is the listing. Next, we need to provide the join column decorator, which if we look at the description, we can see that it's used on the one-to-one relationship to specify that we are the owner of the relationship, which in this case we are. So let's mark this with join column. So now that we've updated the item with a listing property, let's go back to the create item DTO, where we will update this to now accept a default listing. We want to add a new listing property here, and we need to create a new DTO to represent this. So I'll create the new DTO file called create listing.dto, which will export another class called create listing DTO. And inside of this listing DTO, we will just have the description that can be set of type string, and we will set defaults for the rating on this listing. So now back in the create item DTO, let's set the listing as the create listing DTO. Now in our items.service, you can see we have an error because we're not providing the listing. So to fix this, we need to create the listing object by setting a new const called listing equal to new listing from our entities import. And then we're just going to go ahead and spread the create item DTO dot listing to get all of the properties passed into the constructor. And we're going to manually set the rating equal to 0 as our default rating. Now in the item constructor, we can spread all of the create item DTO to get all the properties. And then we provide the listing object that we just created. So now in our entity manager, when we call save, not only will we save the item in the items table, but we're also going to save any underlying entity that the item references through its relations in this call. And that includes the listing here. We're going to save the listing in the listing table because we described this relationship between the item and the listing. However, there is one property we need to set to actually enable this functionality, which TypeORM calls cascades. To enable cascades on this relationship, we'll go back to the item entity, and in the one-to-one decorator, we're going to provide a new options object where we can set cascade to true, which we can see here means that the related object can be allowed to be inserted or updated in the database. So we'll set this to true, and now when we call save, we're going to actually update both of these in the database. Now don't forget that since we have a new entity here, we need to actually provide it to our TypeORM module in the items module. So pass in the listing to our for feature call. Now we can go back to Postman and launch a new request, a post request to create a new item. We're going to give it a name of complex item. We will set public equal to true, and then we will set the listing property now equal to an object where we provide the description and say this is a great item. So we'll send this off to create it, and we get the 201 created response. And now if we go back to MySQL Workbench and refresh all of our data by clicking refresh all, you can see we have this new listing table, and if we select all items on it, we can see that the listing was inserted into the listing table when we just made this request. We have the description, the ID, and the rating. And if we look at the items table now, we can actually see we have the listing ID that actually maintains the relationship between this complex item we created and its corresponding listing in the listings table. Now you'll notice if we go back to Postman and launch a GET request to get all items, we'll get the item back, but we won't get back the listing on the individual item. And that's because by default, TypeORM is not going to populate any relationships on objects unless we manually tell it to do so. So let's go ahead and update our find one route to actually do this. We'll go back into the item service and let's change the find one method to actually populate all relationships. To do this, we're going to change the call to find one and provide the same where statement we did before. We're going to look for the entity by ID, but now we're going to specify a relations property where we can set listing equal to true to tell TypeORM to populate this relationship when we query this item. Now, if we go back to Postman and launch a GET request for this /3 item and fire it off, not only do we get back its properties, but we get all the details from its corresponding listing entry here in the database. Okay, so that's the one-to-one relationship. Next, we're going to check out the one-to-many or many-to-one relationship where A contains multiple instances of B, but B will only ever contain one instance of A. So to see what this looks like, we will have a new property called comments. So we'll call this comments, and just like we did before, we'll create a new entity and corresponding table called comment.entity. So we'll go ahead and mark this as an entity and export class comment. Now it's getting a little tedious to have to specify that ID property in the constructor that's going to be the same for all of these entities. So let's go into our database folder and actually create a new abstract.entity.ts. And let's go ahead and export this class of abstract entity that has the primary generated column of type ID number, which is the auto-generated ID property. We want it to be on all entities. And we'll take in the constructor, which takes in the entity, which will be of type partial t. So we want to make this abstract entity take in a type, and then we can call object.assign this and pass in the entity. So now we have an abstract way of describing an entity. Let's go ahead and actually use it in our new comment by calling extends abstract entity and then passing in the comment. Now we can provide two new columns. The first will be just a basic column called content, which will be the actual content of this comment. Then we're going to go ahead and specify the relationship to the owning entity. So we do this by specifying the item that this comment will belong to. And then we mark it with the many to one decorator, which tells it to return a type of item. And then we take in this item as another function call and specify where on it this property lives. In this case, item.comments represents our comment class here. Now we can go back to the item.entity, and first of all, we can get rid of the constructor now and also extend the abstract entity, get rid of the ID property, and pass in the item type. And then we can specify the comment entity now by passing in the type, and this of course will be an array because this is a one-to-many and many-to-one relationship where we'll have many different comments on a single item. We'll mark this side of the relationship with one-to-many because there will be one item and many comments. And just like we did in the comment class, we'll return the comment type and specify on the comment we want to return comment.item on the item. And you also need to make sure we explicitly import the comment from /comment.entity. Finally, we'll go ahead and specify that options object where we can set cascade to true so we can make sure that when we save an item, we also save all of its comments in the same call. Lastly, let's go back to the listing entity and extend the abstract entity in here, passing in the listing where we can get rid of the constructor and the ID property from it and remove the imports as well. Lastly, go back to the items module and provide the new comment entity to the TypeORM feature call. So we're actually not going to take in any comments in the create item DTO. By default, we want to set an empty array to specify there's actually not going to be any comments on a very new item. So to specify this in our item constructor, let's set the comments equal to the empty array. Now if we go back to Postman and send in a post request to create a new item, we should see if we try to create a complex item 2 and send this off. If we try to get, just like before, we can see we have all of our items with no relationship data. Let's go back and update the item service find one call to specify the new comments relationship and set this to true so that we return back any comments for a single item. And we'll get the comments back on ID 5 of our newly created item. So if we call get now, we can see we get that empty array of comments because there are none. So to actually be able to update and add new comments, I want to update our update call on our items controller, where right now in our update item DTO, we're only allowing it to be past the public property. Let's add a new comments property as well. So in DTO, we'll create a new create comment.dto and export this class of create comment DTO. And this is simply going to contain that single property called content of type string. Now back in update item DTO, we can specify the comments is equal to create comment DTO array. Now we go back to the item service into the update call. We want to loop through all of the incoming comments and turn them into actual real comment objects that can be saved. So to do this, we'll create a new const equal to comments, and set it equal to update item DTO dot comments, and we'll call dot map on it to loop through every comment, and we'll call this create comment DTO. We're going to return a new comment that just takes in the create comment DTO into its constructor. And you can see we have an issue here because we need to explicitly import comment from the entities folder. And now we can set item.comments is equal to comments. And now when we save the entity with the entity manager, because of our cascades, the comments are going to get updated. So before we do this, let's go ahead and take a look at MySQL Workbench to actually look at the state of our database. We'll right click on the database again and refresh all data. And now we see the comment table. So if we select all, right now it's completely empty. So let's go ahead and change this in Postman. We will update through the patch method to our fifth item, and we'll set public to true, but now we'll also add the comments array. Well, we'll provide a comment here with content comment 1, and we will create another comment that has content set equal to comment 2. So now if we send off this request, we have a 200 OK, and if we try to get this newly updated item back with the get call, you can see it has the comments that are saved on it that we just created. Now back in MySQL Workbench, if we refresh the query to get all the comments, we can see we have our newly created comments here, comment 1 and comment 2, that both reference the item ID in this item ID column. So this corresponds to our item in our item table with the ID of 5. Okay, so the last relationship we're going to explore is the many-to-many relationship, which means that A contains multiple instances of B and B contains multiple instances of A. So in order to support this, we're going to have a new table that actually handles all of the mapping or joins between these two many-to-many entities. Let's take a closer look at this with an example on our item. We will now accept a new tags property that can be provided to a given item. It can have multiple tags, and these tags can be associated with multiple different items. So let's create this new tag entity. In the entities folder, we'll have tag.entity. This will be an @entity that will export class tag, which extends the abstract entity, and we pass in the tag. And just like our comment, this is just going to take a single column of type content, and it's going to be a string. So now back in the item.entity, we will now specify this array of tags from the tag entity. And here we're going to specify the many-to-many decorator, which allows us to describe this relationship to the tag. So just like we've done before, we'll return the tag type here and set cascade to true, so we enable cascades. Now finally, we need to also provide the join table decorator that's used in many-to-many relationships, and this is going to specify this join table that we need to handle the mapping between many items and many tags. We'll now accept a list of tags that can be provided by the user. So let's create a new create tag.dto, which is going to be export class create tag DTO that takes in the content of type string. Now back in the create item, we will take in this array of create tag DTOs. So in the item service, we can see we're now complaining in the create method again because we're not actually doing anything with these tags and providing them. So to fix this, we'll do something very similar to this loop we did for the comments. We will have a new const called tags and set it equal to create item DTO.tags.map to loop over each create tag DTO and return a new tag that takes in the create tag DTO. And now in the call to the item constructor, we will pass in this tags array of new tags. Lastly, in our find one call, let's specify that we want to enrich this relationship by setting tags equal to true. Finally, go to the items module as we've done before and provide this entity to our for feature call. And now let's go ahead and create a new item. we'll call post items, and now we'll specify the name of item with tags that will take in a tags array. And this tags array will have a content type blue, say this is a blue item, and we'll have another tag with a content of large to specify this is a large item. Finally, we'll have the listing, which will be an object with a description that says item with some tags. So we'll go ahead and send this request off, and we get a 201 created. If we send a get request off to get all of the items, we can see the newest item with tags has ID 6. So let's go get that individual item, where we can see we have the tags that are now returned back with it. And if we look in the MySQL workbench to actually look at the state of the database, we'll go ahead and refresh all of the data. You can see we have this new item tags tag table, and this is this join table that I mentioned that actually handles the relationship between an item and a tag. Because we have a many-to-many relationship, you can see each one here is going to specify the owning item ID and the tag ID associated with it. So on the item itself, there will be no mention of tags, and similarly on the tag itself, there's going to be no mention of the item because the join table is going to handle all of that relationships. All right, next up, let's look at how we can implement transactions using TypeORM. Now, a transaction in a relational database, or really any database, it's just the idea of maintaining consistency when we have multiple updates to that database in a single request. So to demonstrate this, let's take our update method and temporarily change it so that we can show how a transaction would work in TypeORM. To do this, I'm going to go ahead and comment our existing update code and have a new block where we will do a transaction. Now to start, we'll call await this.entityManager.transaction, and here we get the async method with an entity manager provided, and we simply can execute all database operations in this callback using this entity manager, and it will be run inside of a transaction. Now what this means is if at any time in this callback an error is thrown and we don't complete the whole transaction, then all database updates in this callback will be rolled back and nothing will persist. So let's go ahead and take a closer look at this. So we'll copy our commented code right now and paste it in the callback. And instead of calling this.entityManager.save, we're going to use the one passed into us where the transaction is taking place. Now let's say after we save the item in our database, we want to take that item, send it to some external service, and get a new tag that's generated just for that item using some of the data on an item. So to simulate this, we'll go ahead and create a new tag that's going to be equal to just some random value. So we'll open a template literal and call math.random to generate this new tag. So we'll set this equal to tag content, and then we can create the new tag by calling const tag equal to new tag and pass in the content of tag content. Now we'll call await entity manager.save and save this tag. So you can see we have two different writes to the database happening, one for the item here and the subsequent save of the additional tag. Let's go ahead and try updating our most recent item. So we will update using the patch method on item 6, and we want to change the public property to false now. And we'll go ahead and add a empty comments array and send this off. So we have a 200 OK, and of course we can get back the item with the public set to false and our comments sent to an empty array. So this update did succeed. Now if we go to MySQL Workbench and run a query to get all the tags, we can see we had this new randomly generated tag that got added to the tags table because of our second write on our update call. Now to simulate a failure in this transaction, I want to throw an error by calling throw new error right after we save the item. So after we save the item, we're going to throw an error, and we should see that the item gets rolled back and our update is not persisted to the database because of this error in our transaction. So let's test this functionality out. We'll go ahead and get the current state of item 8 in our system by calling get/8 to see that it currently has no comments. So now I want to send a patch request to update this item and actually give it some comments. So I've gone ahead and updated my payload here to represent the comments array. And now if we send off this request, we of course get a 500 internal server error because we are throwing an error. However, now if we actually get the item again, we can see that it still has no comments being generated, even though our error is being thrown after we save the item. This transaction rolls back this write, and we're left with the original state of the item with no comments. All right, next up, let's look at event subscriptions using TypeORM. So event subscriptions are going to allow us to listen to a number of different events to our data and our tables and actually respond to them programmatically. So we can see how this can be done really easily. Let's go into our items folder and create a new file called item.subscriber.ts. And we're going to decorate this class with an event subscriber decorator and export a class called item subscriber, which is going to implement the entity subscriber interface and we'll pass in the item entity that we're subscribing to. Next, we'll have a private read-only logger set equal to new logger from NestJS common and pass in the item subscriber.name. And then in the constructor, we're going to inject the data source from TypeORM and make sure we call data source.subscribers.push and actually push this class to the subscribers array. Then we'll go ahead and specify a listen to method that simply returns the entity we want to listen to, in this case the item. So now at this point there are a bunch of different events we can subscribe to in TypeORM. I'm going to leave a link in the description where you can see a list of all of these different events that we can subscribe to. I'm going to show you two different events. The first is called before insert, and we can even see all of the different kind of events here that are start with before. We're going to use before insert, where we can see we get the item, which is an insert event of type item. Let's go ahead and call this .logger.log, and we'll say before insert, and the second property we'll call json.stringify, and just stringify this event to the console. Next, we're going to have the after event, where we can call after insert, and we'll do the same thing. So we'll copy and paste this log statement and just call this after insert. And importantly, instead of stringifying the entire event, we want to make sure we stringify the event.entity, which is where the actual entity, or in this case the item, actually lives on that object. We want to provide this to the provider's array, that is the item subscriber, to make sure NestJS knows about it. So now back in Postman, we'll send a new request to create a new item with a name of item with tags plus events and send this off to post/items. You can see we have a 201 created. And now if we look in our console logs, we can see the before insert log with the item that we are inserting. And then we can see the after insert call with the object log to the console. So there's a bunch of different events that we can subscribe to, and this can be super useful when trying to do things like listening for data changes and mutations in our system. And TypeORM makes this very easy to do with event subscriptions. Next up, I want to show you how we can execute migrations using NestJS and TypeORM. Migrations are going to allow us to seed and change data every time we start up our application or execute a command. So in order to do this, we need to specify a new file at the root of our project called typeorm.config.ts. And this is going to be the data source that we expose to the TypeORM CLI to actually connect to our database. So in here, we're going to export default new data source from TypeORM. And here we have the options object where we provide the options just like we did in our Nest application. This time we'll specify the same type of MySQL. And now we need to provide all of the environment variables to connect to this database through the config service, just like we did in Nest. So to make sure our environment variables actually get loaded, we need to open up our terminal and make sure we npm install .env, which is the underlying package NestJS uses in its config module. We're going to call the same method to initialize our environment variables, which will be config. So call config, and we import this from .env. So this is going to load our .env from the root, we can see. And now that we've loaded in, we want to get the config service and set this equal to new config service from NestJS config. So now we can actually use the config service. Let's go to our database.module and copy and paste all of these environment variables into the TypeORM config. And in doing this, I see we have a typo in our config service here. Let's go ahead and replace this all at once. In VS Code, I'll search for this typo and replace it with config service to update this in our TypeORM config, as well as the database module. So now it's config service correctly. So we're providing all of the env variables from our .env to connect to the database on the CLI to execute these migrations. The one other thing we need to take care of is to provide the list of entities to this data source. Now in our Nest app, we had the ability to do this automatically through this auto load entities property. However, the same cannot be done through the data source directly. So we need to load our entities manually by calling all of our entities in our system. So we'll add the item, listing, comment, and tag as all of the entities in our system. Finally, let's go ahead and specify a migrations property where we're going to specify that all of the migrations in our app are going to live in a migrations folder and set a wildcard so that all files in this folder will be run as a migration. So in the root, we'll create this new migrations folder where all of these files will live. And now we can actually set up our package.json scripts to generate and execute these migrations. First up will be TypeORM create migration. So this script is going to use npm directly and call npm run TypeORM. So we need to be able to reference TypeORM directly in our project. So to do this, we'll add this TypeORM script, which is simply going to execute ts node and go into our node modules folder, into TypeORM, and execute the CLI command. So now that we can actually execute the CLI, we are going to call migration create and specify that we want this migration to be generated to our migrations folder by using /migrations/npm config name, which is going to take the name of our migration we want to create. So let's go ahead and test this out on the terminal. We're going to head and run npm run TypeORM create migration, and then specify the -- name, which we want to be called public items, because in this script, we're going to go through our items table and set all of them to public. So let's go ahead and run this to generate this migration. And now we can see in the migrations folder, we have this new file that has the JavaScript timestamp as well as the name public item. In here, we have two methods that will be implementing this migration interface. So each one of these methods takes in the query runner, which we can use to execute raw queries against our SQL database. The up method will be called when we want to execute all migrations, and the down method can be called to revert our migration. Let's see how we can do this by calling on the query runner, query runner.query, and here we're going to call update item set public equal to 1 because we want to update all items to make them public. Now in our case, we're not going to have a down method, so let's just simply have a new private read-only logger in this class. From NestJS common, we'll pass in the constructor.name and make sure we call this .logger.log. I'll specify up for the up method, and in the down method, we'll log that we are going down. And we don't need to use the query runner. So back in our package.json, let's add the two scripts we need to be able to execute the up and down methods. We'll have TypeORM run migrations, and this is going to be equal to npm run TypeORM migration run. We'll pass -- and then pass -d to specify the path to the TypeORM.config.ts, which specifies how to connect to the database. We'll go ahead and copy this command, paste in revert migrations, and simply call migration revert instead to execute the down function. So before we try this out, let's go to our database now and look at all of our items to see the state. We can see all of them are currently public, so I'll go ahead and set a few of them to 0 to represent that they are not public. Now let's go ahead and execute these migrations by going back to VS Code, and in the terminal we can run npm run TypeORM run migrations. You can see a bunch of different information here, including the actual queries that the migration runner ran, including our query here where we called update item to set public. And here is our up log statement inside of our migration script. And you can see that it has been executed successfully. So if we go back to the database now and refresh this query, we can see they've all been reset back to being public because of this script. Lastly, if we want to show that the down method can be run, we'll just call the same function, but now we'll call revert instead of run. We can see the down log statement. Let's take a look at how we can do unit testing with this TypeORM integration. So in our items.service.spec right now, we can see we have a test for our item service that just checks to see if the service can run. So let's go ahead and try running this by running pnpm test items.service. Now you can see the test has failed because we aren't providing a provider for the item repository, so it really has no idea where to get this from. TypeORM makes this really easy for us by providing a special function to be used in these unit tests, and we can make use of it by going to the providers array and providing a custom provider. The provide property is going to be key here. This is where we call get repository token from NestJS TypeORM, and then pass in the entity we want to get the repository for. Of course, we know from the item service, this is the item here, which we pass in to inject repository. So let's pass in that same item. Then for use value, I'll just pass in an empty object to represent our mock repository. You can set this to any property you want and mock these methods and listen for them to be called in your tests. So now if we run the same pnpm test to run the item service, you can see it's still failing, but now it can find the repository. It just has an issue finding the entity manager, and this is also expected because we're not providing it. So let's do the same thing here. Now in this case, we can reference the entity manager directly from TypeORM, and we'll just give it a use value of an empty object as well to represent an empty mock. Just like for the repository, you can fill this in with mock methods. Let's go ahead and run the test to see it get executed. We can see the test is now passing. So let's go ahead and show you how we can actually write a test for one of these methods. Let's go ahead and test the find all method. So this is a very simple method. We want to just test in the item service that when we call find all, we're calling find on the items repository. So let's go ahead and firstly get access to the items repository so that we can reference it. In the test here, we'll have a new let items repository set equal to repository of type item. Then we'll get it by setting item repository equal to module.get, passing in repository item to give it a type. And then we can pass in get repository token to get the repository token for an item. So now that we are actually getting the items repository, we need to mock the method on it. So let's do this in our use value. We're going to set find equal to jest.function, which will mark this as a mock function. Now in find all, we can say that we want to call our service.findAll, which is asynchronous. So let's set this to async, and we'll call await. And now we can expect by calling expect items repository dot find to have been called. So we're looking at this mocked object and the mocked function on it. We're saying this should have been called when we call find all in our service, which is what is happening in the method. So let's see if this test will now work. We'll open up a terminal and execute pnpm test items.service. We can see the test has passed and we are successfully calling the items repository. So we can see how easy it is to mock both the repository and the entity manager in our tests. So I hope you've enjoyed this deep dive into TypeORM and NestJS. This integration is really great and powerful and allows us to build RESTful APIs with SQL very easily. Thank you so much for watching, and I will see you in the next one.